Hi, I'm Josh Mitchell and this is my entry into the 2017 Big Bang Engineering Competition. My project is called the Desktop Workshop. It's a combination CNC mill and 3D printer in one machine. Quick overview. How it works is the hot end for 3D printing or spindle for milling is attached to here. This moves that way, and then the Z-axis, this moves that way. So say if it's going to print, this plate will be up here. This would have the hot end and move. Say if it's going to do a square, this would move in a square. Then this plate would move down. That would move in a square again. This plate would move down. Same for a mill, except this would move up instead, as that would cut the material rather than extrude it out. Start off with the frame. This was milled out of MDF on my CNC router. You don't have to use a CNC router. I had one, so I used it. Yeah, it's held together with these M6 bolts going into these cylindrical bearings. Don't really know what they're called. But these, so it clamps these top plates and bottom plates to the side plates. Makes it a really rigid structure. This is also acts as a container for the electronics. I've taken the electronics out to demonstrate what it is. This is the power supply, 12-volt computer power supply, which fits there. Really overkill for this project. You only need like a laptop power supply or even just a wall wart. That 12-volt wall wart, that worked fine. This is the electronics that the 12-volt feeds into. This is called a RAMPS board. Repart Arduino Mega Pololu Shield. It stands for. It's designed for 3D printers. Has these 3 stepper drivers to drive these 3 stepper motors. It also powers the hot end, so it powers the heater cartridge, and also protects the resistance of the thermistor, so it can regulate the temperature, keep it in a set range. It also powers the LCD. This LCD will go and that cut out for it there. It allows you to control it without the computer. So moving on to the Z-axis. The Z-axis is powered by this stepper motor there. If you can see it, it's a bit dark. But this stepper motor, so that's embedded into the MDF. This stepper motor has a pulley on top, and when that pulley turns, it turns this timing belt through these tensioners. These are just skateboard bearings, and then onto these pulleys on the M8 threaded rod. And as these M8 threaded rod pulleys, you can't see it, but these have bearings, skateboard bearings, just under here and at the bottom, embedded into the MDF. That keeps these from moving up and down, and also gives them smooth rotary motion. But there's also a captive M8 nut there. So these stay stationary, whereas when you move it, I'll do now. This plate moves up and down, and it's the same on all 4 of these corners. As for the linear motion, has these V-groove bearings attached to this same steel angle that's used for the frame. That's just screwed into this MDF plate. These are tightened up against the frame. These are only 30p each, so overall it's £1.4p for all. We use 8 of them, and obviously the frame's already there. So it's really cheap, really rigid. There's no play in it whatsoever. Moving it my hardest, there's no play. So it's really rigid, and also as it's tied into the frame, like say if the X-axis tries to like the spindle tries to mill out something that way, this would obviously move that way because it would exert an opposite force back that way. So it's called this whole frame to flex, and obviously I can't take out all the flex, but that also means that as this frame moves that way and this is connected directly to the frame, this would also move that way, so it will kind of automatically compensate for any inaccuracies. Not fully, probably only about 60-70%, but still that's a massive increase in accuracy, and that's one of my main design concepts. So right, onto the XY axis. This is the vertex this is where the hot end or the spindle will mount. Hot end for 3D printing, CNC. Hot end for 3D printing, spindle for milling. Has bronze bushings here to allow rotary and linear motion. And how it works is these stepper motors pretty much just drive that, and that, say if it moves that way, if it rotates that way, it'll move that way, and as this is coupled to this rod, which is also coupled to this would also move that way, so this whole rod moves that way. Same on the x-axis, but in the other direction, so this can move anywhere in the XY plane just by regulating how much you move these stepper motors. And as this machine is a combination mill and 3D printer, what I've done, well, the main difference between a mill and a 3D printer is that a mill has a very high torque and very low speed. But the 3D printer is an opposite. It has a very low torque but very high speed. So what I've done is I have two gears, one on the inside, one on the outside, and then this stepper motor has a gear here. So right now it's engaging the outer gear, which has a mechanical advantage of 4, so it goes 4 times slower but 4 times more torque. Then that's for the CNC milling. But if you want to engage the 3D printing, you just move that down to there, and then that's a 1.2 mechanical advantage when it engages the middle gear. So yeah, that's 3D printing, and snap it back up for the milling. Same on this axis. I am going to replace all these 3D printed parts with aluminium parts. If I do get through to the finals, I couldn't justify spending the money on aluminium parts if I didn't get through to the finals. But these will be replaced if I do get to the finals. And yeah, I'll show a little bit of motion. So yeah, that's how this actually works. Yeah, that's it.